Yeah, so hello everyone. Um, Now we've come to week 9, so let us begin this session without any further delay. Okay, so I'm Catherine Sanchna, a PhD scholar from IIT Madras. So this session is between 6 p.m. and 8 p.m. every Monday. So if you have any queries, you can also view the session on YouTube. The link for which will be provided in the NPTEL website for this course. And if you have any queries, you can post in the discussion forum or even comment in the below the YouTube video. So I hope I'm audible and the slides are visible. So yes, last week we were seeing about horizontal and vertical alignments, and we stopped with horizontal alignment. So I've changed the mode of content delivery. So earlier I used to discuss last week's content for the first one hour, and the remaining 1 hour we will be solving questions. So for the past 2 weeks, I've been solving questions, and then and there I've been giving inputs about the content, okay, according to the question. So last week I stopped with horizontal alignment and for vertical alignment, we will begin with vertical alignment this week and also finish the rest of last week's portions, which is interchange. Introduction about interchange. Okay, so what I've explained about interchanges. So we will get into that, and by this week we will finish. We will not be. I hope we will not be having any backlogs. Okay, I think we will be able to finish the entire week 9 content this week itself. Okay, so let us begin with the first question, which corresponds to last week's extension. Okay, so the first question is the current statement with respect to the summit curve is okay. Since this question has brought out the topic of summit curve, let us first have a brief understanding about vertical curves and some of which summit curve is a part of it. Okay, so you have for vertical alignment. So we saw that vertical alignment means a change in grade. Okay, so a change in level. So if one section of the road, longitudinal section, is at one level, and if another section of the road is at another level, then these two have to be connected by something called as a gradient. Okay, okay, which we normally call it as grade. So this is has a positive gradient because it connects from the lower to upper level. There's one more gradient where you connect from the upper to lower level. Okay, so based on the gradient or based on we will see the types of gradient, but I mean types of curve for vertical alignment. So one is summit curve and one is valley curve. So I told you that here you have something called as gradient. Okay, so this is a gradient. Okay, but if two gradients connect together, then it will result in a curve. Okay, just like you have a horizontal curve when you observe from the top, if you observe a road from the top, you can see a horizontal curve like this, right, on the same grade. In the same way, you can also see a vertical grade like this or like this. Okay, so this is an elevation. So horizontal grade, you can see it from the top, which is we can say plan view or top view. This is you can say the front view or the side view. Okay, something like that. So if two grades are connected together, then so this is a grade, and if two grades are connected together, it will result in a vertical curve. So this is called a summit curve, okay? And this is called a valley curve. Now, how will you find out if a curve is a summit curve or a valley curve? See, if you see, these four are examples of summit curve, and not all the curves are like this exact do not have a exact convex shape. So you call this as convex shape, right? And this you will call it as concave shape as per physics. Okay, this is not how we define curves as in highways, but for identifying the shape, I'm telling you that this you will call it as a convex shape and this you will call it as a concave shape, right? But if you see here, and just now I told you that this convex shape results is called as a summit curve, and this concave shape is called as a valley curve, right? But if you see all these four examples, they will not look exactly as what I told you, except for the C, where it has a convex shape. The others, okay, it will not have a perfect convex shape. But how will you identify if it is a summit curve or a valley curve? That is very simple, okay? Now, I told you that this is an upward gradient, and so this will have a positive sign, okay? And this is a downward gradient, and this will have a negative sign. So how will you usually define a grade? The unit of grade is, it is actually unitless because, see, what do you mean by a grade? Grade is the number of, so let me move to a new slide. So what is grade? Grade is vertical distance when you move. So the rise in the vertical distance when you move some horizontal x distance. So let us say for an x distance of y, there is an increase in the vertical distance of for a horizontal distance of x, there is an increase in the vertical distance of by y. Okay. Now, how will you define a grade as grade is the rise in the vertical gradient, I mean, the rise in the vertical direction, which is y, divided by how much distance you have traveled in the horizontal direction. So this is x. Since both have units of meters, grade is actually unitless. Okay, it is just a fraction. But mostly we will express this grade as a percentage. Okay, so it will be expressed in percentage, or you will also call it as a 1 by n. What is 1 by n? How much meters, how much meters or kilometers, whatever. How much meters? So if I use meter in the numerator, I should use meter in the denominator. Okay, so they should be of the same units. Even if it is length, it should be meters, meters, or kilometers, kilometers, like that. Okay, so how many for 1 meter rise in the vertical direction, what is the distance you have to travel in the horizontal direction? That is n meters. Okay, so this gradient is either given by 1 by n or it is expressed as percentage. Okay, now this is how a gradient is expressed, and I told you that a positive gradient, okay, a rising gradient will have a positive value, and a falling gradient will have a negative value. Usually, a summit curve is formed when a positive gradient, so this is not usually, okay, so this is how you can imagine, like how I told you this curve is concave is because a rising gradient, okay, gradient is the tangent at a point, right? So you draw a tangent at this point, a rising gradient, when it meets a falling gradient, you will have a summit curve. But it is not always the case. This is one example of summit curve. Okay. If you see this figure, the first gradient is positive, the second gradient is zero, which means that it is simply a flat surface. Now let us see this case. The first gradient is positive, the second gradient is also positive. Now come to the fourth case. Okay, the first gradient is negative and the second gradient is also negative. Now Given this case, how will you identify if it is a summit curve or a valley curve? Because not always you will be given pictures like this. So if it is easy to figure out from this picture that all are summit curves, right? But yeah, so that all look convex in shape, and so all are summit curves. It is easy to see from this picture. But once, if you are given a problem, and they will simply write it as a statement, they will say that a grade of a falling grade of say n1 percentage. So if I want to describe this person, a falling grade of n1 percentage meets another falling grade of n2 percentage. Now both are falling gradients. How will you identify if it is a summit curve or a valley curve? In such a case, what you should do is, generally, they have a general definition, okay, to define a summit curve in such cases. So what is that general definition? That general definition is, you have to find out the algebraic difference between the two grades. What do I mean by algebraic difference? I should take two grades and I should subtract it, right? That is called as difference. What do I mean by algebraic difference? So when this term algebraic comes in, it means that I should take the sign of the gradient also into consideration. So it doesn't mean that I should just take the numerical values and find the difference, but I should consider the gradient as it is, including the sign of the gradient. Say if you see this, so what is the algebraic difference? It is n1 minus of, again, minus n2. So this is the algebraic difference. I have found out the difference but between the two grades, but the sign of the gradient is also maintained the same. So what will this give me? This will give me n1 plus n2, right? So this is positive. If the algebraic difference between the two gradients is positive, then it is always a summit curve. Okay, you need not worry if a rising gradient is meeting a falling gradient, or if a rising gradient is meeting a rising gradient. You need not have any confusion about it. Just remember one thing, that this difference, this thing that I told you is represented as capital N, and it is nothing but the algebraic difference, right? So it is the algebraic difference between the two grades. So if it is positive, if it is greater than 0, then it is a summit curve. If it is less than 0, then it is a valley curve. So this is the basic definition that you should know. Now, coming to this problem again, the correct statement with respect to the summit curve is what? So they're asking you to pick the correct statement. It is concave upward, it is concave downward, and the vertical point of intersection lies above the curve. Okay, so you know that this is the curve. For a summit curve, the point, you know that this is the point of intersection, right? The point where these two tangents meet is the point of intersection. In summit curve, if you see from all these figures, the point of intersection should always be above the summit curve. So the second point is correct. Let us see if the first point is correct or not. So it is convex downward. So what is convex downward? So this is convex downward, right? And this is convex upward, right? So this is not the correct answer, because even though the second statement is correct, the vertical point of intersection should lie above the curve for summit curve, the convexity, the statement which talks about the convexity is wrong. So it is not convex downward but convex upward. So let us find out which option has both these two correct. Okay, so it is convex upward, and also the vertical point of intersection should lies above the curve. So the correct answer is D. Okay, if you have any questions, please stop me in between. Now moving on to the next question. So all these figures belong to the solution which I added. Okay, so you will have only this question, and as I told you, they will not give you any figures, but they will just write it as a statement. Okay, Here they have specifically mentioned that it is the summit curve, but many cases, or in some cases, they will just give you tell you that it is a vertical curve. Okay, so how will you identify if it is a summit curve or valley curve? We saw that it has to be identified by using n, right, which is the algebraic difference between the two grades, okay, forming the curve. Now, an upward gradient of 1 in 50 meets with a downward gradient of 1 in 50. So what did I tell you? Let us take the first gradient as n1, and if it is an upward gradient, it should have a positive sign, right? And it is given that this gradient is 1 in 50. I told you that gradient is given in percentage, or it is given by 1 by some value. Okay, so that we call it as not 1 by 50, but we will call it as 1 in 50. Okay, so the first gradient is an upward gradient of 1 in 50, so it is positive 1 in 50, and it meets a second gradient, okay, which is a downward gradient. Okay, what did I tell you a downward gradient should have? It should have a negative sign, and that also has the same grade. Okay, numerical value is the same, so it also has an absolute value of 1 in 50, okay, on a national highway. Considering the SSD to be 150 meters, the ordinate of the highest point on the summit curve will be what? Okay, so this is an interesting problem, and now they have given you SSD. What has SSD got anything to do with the length of a curve, right? So you should be wondering why we have SSD all of a sudden when we are studying about curves. But you should understand that if you recall what we discussed many weeks back when we discussed SSD, we discussed that SSD is a minimum distance which should be available for a driver at every point on the road, right? If it is a straight road, you need not worry about SSD at all. But if it is a curve, maybe it can be a horizontal curve or a vertical curve, then you have to ensure that when the driver is let us say that SSD is 150, let us say that SSD is 150 meters, for example. When the driver is at this point, some distance will be visible to him, right? Some distance, and that distance should be equal to minimum. It should be a minimum of 150 meters. Now from this point the driver has moved to this point because he is moving forward in direction, right? So when he moves to this point, he will be able to see some increased distance, right? And that distance should be at least 150 meters. So when the driver keeps on traversing along the curve, at every point on the curve, he should be able to see at least 150 meters, at least a distance of 150 meters ahead of him. So SSD plays an important role in the length of the curve, right? So um, even for even for horizontal curves, right? We saw when we studied SSD, we calculated it based on two formula. One is the length of the curve less than SSD and length of the curve greater than SSD, right? So there, in that case, length, finding out the length of the curve was not a problem because it was just a circular curve with a constant radius. Mostly when we studied about horizontal curves, when we studied about SSD and horizontal curves, it was just we were talking only about simple curves, not complex curves or compound curves, right? So in that case, finding out length of the curve was easy, but you focused more on finding out the SSD for this length of the curve. Now for this curve, okay, for vertical curve, it is not a circular curve. A vertical curve is not usually a circular curve, okay? It is not a circular curve, but it is a parabolic curve, okay? You should know the equation for this curve in order to fix the curve, okay, on the road, and also um, you should be able to calculate the stopping side distance. In this case, the stopping side distance is also here. Here also it is related to the length of the curve, and you have to formulate to find out the length of the curve or stopping side distance. Okay, if you have one, you can find out the other. It's like that. So one formula for length of the curve less than SST, and one formula for length of the curve greater than SST. Now I told you that the vertical curve is a parabolic curve and it is not a simple circular curve. So you need to know the equation of this parabolic curve and how it was obtained. So let us see that first, and then we will move to the question directly. So first let us discuss about the basics. Okay, I told you that it is a parabolic curve. Now what is the equation of a parabolic curve? We all know that the equation of a parabolic curve is y is equals to ax square. Okay, you have four types of parabolic curves, right? One is like this, one is like this, one is like this, sorry, like this, and one is like this. Out of these four, which one? Um, so these two will have an equation of x is equals to ay square. Okay, and these two will have an equation with opposite signs. Okay, one will have x is equals to plus ay square, and the other one will have x is equals to minus ay square. Okay, so these two are related like that, and these two will have an equation of y is equals to ax square, with one having y is equals to plus ax square and the other having y is equal to minus ax square. Okay, so based on this formula, you know that how a vertical curve looks like, right? It looks as if it has an equation of y is equal to ax square. Now we know the basic equation, but this is a this is a coefficient. This is the coefficient of x square, and you need this value to be only when you need only. So this is the general equation of parabola. To find out the equation of your curve, you have to find out the value of a. Now how will you find out the value of a? So for that, let us take this figure. Okay, so from here you will calculate x like this. X will go like this. Okay, and you draw a tangent from this starting of the curve, okay, to the end of the curve here. Okay, to the end of the curve you draw a tangent. Now this is my curve, so this red line is my curve, and the point from this curve to this tangent, the vertical distance from this point to this tangent is my y. Okay, so when x is equals to say this distance, my y distance is going to be this much. Okay, in this equation, if my x is this distance, let us say for example if it is 5 meters, and if at this point my y is say 0.1 meters. Okay, if you substitute that in this equation, you can find out the value of a. Now here you do not know the value of, so you know the value of x. You can easily find out the value of x. It varies from 0 to L, right? But y, you do not know the value of y. You have to calculate the value of y based on this figure and then substitute it in this equation to find out the value of a. So basically, given a general equation, you can find out the coefficients associated with the equation by substituting for the values of x and y. Given you should substitute the exact values, right? So for a given x, you should find out at that point what is the value of y. Only then you will be able to find out the value of a. Now you know that this entire distance is L, right? And you this distance I told you, right? The vertical distance from this tangent tangent to this curve. So the curve comes like this and ends here. So this distance is my y. So if I find out what this value of y is, I know the value of x, I can substitute it in this equation and find out the value of a. Now how to find out the value of y? This is very simple, right? So this is my curve, and at the start you have a tangent, at the end you have a tangent. So just take it as a tangent. Okay, at the end you have a tangent. Now this has a slope of n1 and this has a slope of minus n2, right? So this slope of this is n1. Okay, so this distance, so this slope is n1. So what is slope? Slope is the angle made by the line. So slope of a line is the angle made by the line with the horizontal, right? So what I say, when I say it is the ratio of vertical to horizontal, it is nothing but my tan theta or theta. Okay, so this is my slope. I hope it is clear. Okay, so this with the horizontal, how much angle this line makes is my n1, and this n2, this also with the horizontal. So this is horizontal. How much distance it makes with the horizontal, how much slope it makes with the horizontal is n2. That is why this entire angle becomes capital N is equals to n1 plus n2. Okay, I hope this is clear. If you have any doubts, please stop me in between. Okay, now this is my n1 and this is my n2. Now this forms a triangle DEF, and this forms another triangle DFC. Okay, so there are two triangles. So based on these two triangles, using Pythagoras theorem, you can find out the length. Let us call this as L1 and let us call this as L2. So how will you find out L1? Okay, so tan theta, just take tan theta at this point. Okay, tan theta is nothing but slope. Your n1 is my slope. Slope is nothing but tan theta. So both can be equated. So tan n1 is equals to tan theta is equals to opposite. Opposite is L1 divided by adjacent. So tan theta is what? Opposite by adjacent, right? So this is my adjacent value, right? This is nothing but L by 2. So if the entire distance is L, at midway half, it is L by 2, right? So my L1 is nothing but N1 into L by 2. Similarly, for L2, again take tan theta. Okay, tan theta is nothing but this tan theta of this triangle. Okay, so this is nothing but N2 is equal to opposite by adjacent. So here my opposite is L2 divided by adjacent is the same horizontal distance, which is L by 2. So L2 is nothing but N2 into L by 2. Right? Now, what is this total distance? This total distance is my y, which is equal to L1 plus L2, which is L by 2 into N1 plus N2. We saw that this N1 plus N2 is nothing but R capital N. Okay. Now we know the value of x is equals to L, and for this x is equal to L, we have y is equal to L into n by 2. Now substitute this in this equation of parabola ax square. So L n by 2 is equals to a into L square. So what is my a? A is nothing but n by 2L. Okay, so this is my, so y is equals to n by 2L into x square is the equation of my parabolic equation for my vertical curve. Now you how will you find out the highest point on this curve? Okay, So to find out the highest point of this curve, just substitute n1 into L by n, right? Just a second. Yeah. To find out the highest point of this curve, just substitute x is equal to L by 2. Okay. When you do that, okay, just substitute this there in this equation. So y is equals to, so highest point of this curve is nothing but my y. Vertical distance is what they've asked. Okay, and it occurs at a distance of L by 2. So just substitute this there. Okay, L square by 4. You will get n L by 8. So this is the highest point on the curve. Okay. Now let's go back to the question. I hope all this is clear. Okay, so the question is they've given n1, n2. We just found out what capital N. So we have to find out capital N from this n1 and n2. We saw small n1 is 1 by 50 and capital, this is minus, right? And capital N1, N2 is, sorry, and N2 is minus 1 by 50. So N is the algebraic difference between the two, right? So it is going to be 2 into 1 by 50, which is 1 by 25, right? Now they've given you SSD is equals to 150 meters and they've asked you for the highest point on the summit curve. Just now we saw that the highest point on the summit curve is NL by 8, right? This is not, so this is the highest point on the summit curve. Now, in this equation, you know what is the value of N, but you do not know the value of L, and that is what you have to find. For that only, they've given you SSD. Okay, so I told you that there are two equations to find out the length of the curve, okay, based on this SST. So when length of the curve is less than SST, there is a formula, and when the length of the curve is greater than SST, there is a formula. Now there is a now you must have a doubt. You do not even know the length of the curve, but how can you say? How can you use pick the formula based on whether it is lesser than SST or whether it is greater than SST? So now you simply have to make an assumption. What you have to do is just take the first formula. Assume that your length of the curve is lesser than SST and use the formula. So the formula corresponding to L less than SSD is um, just a second. Yeah. Okay. I missed the formula somewhere, but first let us go with L greater than SST. You can pick either of the two. Okay. First step is, so I will tell you the step first. First, just assume that L is greater than SST or less than SST. Then using the formula, find out what L is. If you know the value of SSD now, it is 150 meters. Now, if the um, length of the curve is greater than SSD, so you would have found out a final value. If this if this is 250 meters, then the assumption that you've made is correct. Then you can go ahead and use the same for then you can go ahead and say that my length of the curve is 250 meters. Now, for this assumption, if you're getting the length of the curve as 100 meters, you know that for the SSD that they've given, comparing the length of the curve with SST, your L is less than SST. In such a case, the assumption that you've made is wrong. So in such a case, you have to go to the second formula. You should say that this is not true. So let us assume that L is so this is not true. So L is lesser than SST, and then find out L based on the second formula. It will definitely satisfy. So L will definitely be less than SSD in this case when you use this formula. Then you can go ahead and solve the rest of the problem. So for this problem, first let me assume that L is greater than SSD. Okay. So for this case, the length of the curve is ns square by 4.4. Okay. This S is nothing but SSD. So substitute this in this equation. So what is my n? N is 1 by 25, right? So 1 by 25 into S square is 150 square divided by 4.4. So for this, you will get L is equals to 204.45 meters. Now you made the assumption that L is greater than SSD. Is it greater than the SSD? SSD? Yes, it is greater than SSD. So you can take this as the final value of length of the curve. Okay. So my length of the curve, I got the length of the curve, but this is not the uh, question that they've asked. They've asked you to find out the highest point on the curve, which is n into L by 8. So 1 by 25 into what is L? Let us take this as 205 divided by 8. So this is going to be 1.0227 meters. So this is the final answer. So I told you that n n1 or n2 is expressed can be expressed as percentage, right? But whenever you substitute it in a formula, you should always use it as a fraction, unless and until it is an empirical formula which specifically tells you that you have to use it as a percentage. You have to use it, unless it is told like that, you have to use it as a fraction. Okay, so this has to be kept in mind. Now moving on to the next question.
Ma'am, one doubt, ma'am.
Yeah, yeah, yeah.
Yeah, this L, n square by 4.4, we are calculating the L, no?
Yes, yes.
That is the
Yeah.
length along the curvature, isn't it?
It
That
is,
L is
no,
length along the curve,
not length along the curve. It is the projection of
or
this.
it is a
It is the projection.
horizontal.
Horizontal
It's
distance.
horizontal
Yes.
distance.
Yes. It
SSD.
doesn't,
What do you mean by SSD? SSD.
SSD
It's
is,
also a horizontal distance.
no, it is not a horizontal distance because your vehicle will be traveling on the curve. So SSD is calculated according to the, along the length of the curve. Only then you will be able to stop, right? You cannot take a projection of that.
Okay.
Whereas
Okay.
length
SSD
of
is
the
along the curve.
uh, where
Right. Okay.
for vertical curves it is always the projection of the vertical curve. Length is always the projection of the
Okay.
vertical. Yeah.
Okay. Okay.
I will also confirm this once again next week, and I will definitely let you know next week also. Hello.
Okay.
Yeah, yeah.
Okay. Okay.
Okay, yeah. So moving on to the next question. A valley curve is formed by joining a downgrade of 3%. So let us take the first gradient as 3%, and it is said that it is a downgrade, so it has to be negative, and an upgrade of 2%. So my second grade is a positive grade, 2%. The design speed on this section is 80 kilometers per hour, and the rate of change of centrifugal acceleration is 0.6 meter per second cube. Based on the comfort criteria, the length of the curve in meters would be what? So we wrote all this information, but first let us discuss about valley curve, okay, and how to find out its length, and then move on to the problem. Okay, so we saw that. So exactly opposite to the summit curve, the point of intersection will lie below the curve, and also your capital N, which is the algebraic difference between the two grades, okay, that has to be less than 0. Let us check for this case, okay. N1 is minus 3%, N2 is plus 2%. Now what is N? N is N1 minus N2, which is minus 3 minus of plus 2, which is minus 5%. So this is less than 0. So this is a valley curve. Okay. Now, so this is, so it is just exactly opposite to a summit curve. Now, there are, so you saw for uh, for summit curve, the equation of the length of the curve was given by SSD, right? But here you have two uh, two methods to find out the length of the curve. One is comfort criteria. What is this comfort criteria? If you see, if you're traveling on a vertical curve, right? If this is your vehicle, your gravitational force will be acting downwards. And when we saw the problem, so when we discussed about the horizontal curves, we saw that when you're traveling on a horizontal curve, you will be pulled outwards, right? So, and that we saw that as the centrifugal force, P, right? In the same way, when you're traveling on a vertical curve also, you will be pulled in the direction opposite to the curve. So this, my curve is in this direction, okay, assume that, and it is in this direction, okay, uh, and it will be subject, so the vehicle traveling on this curve will be subjected to a centrifugal force in the opposite direction. So on a summit curve, this gravitational force and this centrifugal force will balance each other, and you will not face a problem, or you will not feel uncomfortable when you travel on a summit curve. Whereas on a valley curve, both the forces will be acting in the same direction. So gravitational force will be acting downwards. Your curve is pointed in this direction. So your centrifugal force will also be acting downwards. So they will not balance each other out. And so you will kind of feel uncomfortable. So they have devised an equation to find out the length of the curve based on this comfort criteria. Okay, so that this comfort criteria is not sacrificed. Okay, so that equation will be L is equals to 2 into n v cube by c the whole power zero point 0.5. Okay, so this is what you saw in the question. You already know the value of n. We found that out as minus 5%. The equation for um, speed of the vehicle was also given as 80 kmph, and this c is nothing but the rate of change of centrifugal acceleration, and that is given as zero point 0.6 meter per second cube, right? So all this has been given. Now based on this, you can find out the answer to the problem. But let us, before this, let us also see the other criteria to find out the length of the curve. So one is the comfort criteria. Why did you not have comfort criteria in summit curves? Because both the centrifugal force and the gravitational force will balance each other. Whereas for valley curve, they act in the same direction, so they do not cancel each other out. So you have a comfort criteria to find out the length of the curve. So the equation to find out the length of the curve in summit curve was based on stopping side distance, right? So here also you should be having one formula equivalent to that, right? Um, so summit curve, valley curve, comfort criteria is not there, whereas for valley curve, comfort criteria is there. Then for based on side distance, so it can be any side distance. So it can be either OSD or SSD, but generally they take OSD. Okay. So based on this side distance also, you have one equation in summit curve and one equation in valley curve. Now I told you for summit curve, you can take either stopping side distance or overtaking side distance. But mostly for conservative design, they will take, sorry, not for conservative design, for mostly for, because if you take OSD, then it is a much larger value compared to SSD. So usually they go with SSD to find out the length of the curve for summit curve. But for valley curve, you will use something called as headlight side distance. We already saw what headlight side distance is when we saw side distance part. But I would like to say a few words about it before we proceed to the problem. Okay, so this is my valley curve. If you see, on a summit curve, your side distance will be a problem. To see that, right? So your side distance will be a problem because the obstacle is at a lower level compared when you travel on the summit curve, right? So your side distance even in the daytime is a problem. But for valley curve in the daytime, side distance is not a problem because when you're traveling here itself, you will be able to see the vehicle or obstruction which is here, and the side distance or the stopping side distance may be only this much. Okay, so even for a longer distance which is available to you in front of you, you will be able to see the obstruction and you can easily stop your vehicle. The problem arises at night time where your the sight or the distance which is visible ahead of you will depend on the distance that could be illuminated by your headlight, by your vehicle headlight, right? In the daytime, you can move your eyes here and there and you can easily see obstructions, okay, on this valley curve. Whereas your headlight is only pointed in one direction. Okay, if this is my vehicle, my headlight will have a beam, okay, light beam, which has a slightly elevated angle, okay. So this is fixed. Unlike your eyesight and your eyesight, or unlike you, you cannot just turn your head here and there and find out, or sorry, turn your head here and there and find out any obstruction in ahead of you. Your headlight, your beam angle, the distance to which your headlight can illuminate is fixed, right? So at night, valley curve will have this problem, and so my side distance, instead of taking stopping side distance, you will take headlight side distance, okay? And there are equations similar to what you saw in summit curve. There are two equations. One, when your length of the curve is less than this headlight side distance, and one when the length of the curve is greater than your um, stopping side, sorry, headlight side distance. Now in this equation you will also have, so there what and all did you have? You had n in the equation and you had s in the equation. So this is my slope, sorry, this is my this algebraic sum, difference of gradients. This s is my side distance, okay, it can be stopping side distance or overtaking side distance. This is in case of, sorry, this is in case of summit curves. For valley curves you will have n s, okay, here this is headlight side distance, this n is the same, and in addition to that you will also have alpha in the equation in terms of tan alpha, okay, you will have tan alpha in the equation, and this alpha is nothing but the angle of the headlight beam. So this alpha is what it is, okay. So this equation, so it is a straightforward equation, you just have to substitute the formula. But for the question that we have, we've been asked to find out the length based on only the comfort criteria, right? So what did we see the comfort criteria equation as? L is equals to 2n v cube by c the whole power 1 by 2. So in this equation, so this is an empirical equation, which means you have to use the values, you have to use the, substitute the values with the units that they have given for the equation. So for this equation, you have to substitute n in terms of fraction, right? Um, v in kilometers per hour, and C in meter per second cube. Just a second. Let me just check if the units are tallied. If not, it is a uh, if not, it is an empirical curve. Okay, meter per second. Yeah, the units are tallied, so it is um, you have to substitute V in meter per second. Okay, so this is not an empirical curve. Just sorry, this is not an empirical equation. Okay, you have to substitute this in just that the sorry, just such that the units are cancelled out. Okay, so N does not have any units. B you have to substitute in meters per second. C you have to substitute in meter per second cube. Okay, then you will get the length of the curve. So length of the curve will be minus 0.05. I told you that n has to be substituted in fraction into 22.22 the whole cube divided by c is zero point 0.6 and this the whole power 1 by 2, and this will give me 60.47 meters. Okay, now moving on to the next question. The design speed on an expressway is 100 kilometers per hour. So V is 100. Yes.
In the earlier question, you can take it as 60 points something, right?
60.47.
47. The answer, correct answer is 60.
60, yeah.
But in the assignment, in the last assignment,
Huh.
instead of 50.21, you are taken 46 for
Uh,
46 you are taken in the previous assignment what we were submitted last week. The
huh.
answer is 54.21. You are
Okay.
take, correct answer is 46. Why that difference? Because
Did I?
I
Hmm.
taken as 54,
Okay.
but the correct answer is 46. There is no mark for this one.
Which problem is that?
It is in the previous eighth problem.
Question,
The same
question number
ditto
8.
question number eight. The same,
Solution also it is given as 54 ma'am answer.
yeah.
But they marked
So
it.
it's taken
They
as
marked it
incorrect.
as wrong.
Yeah, they marked as wrong and they said the 46 is the correct answer.
Because of
And the
that,
and the solution that they have provided, that they justify it as 46.
No, no, it
no,
is
it is
54.
54.21.
It is 50. Okay, then you have to raise a question in the discussion forum. You know about discussion forum, right? It must be
Yeah.
some mistake from the TS side. So if you
Okay.
just mail it to them, they will nullify that marks for all of you.
Okay. Okay. Because
Yeah,
that's why now the same typical question, 60.47, you are told 60, then that
yeah.
is the reason I was asked.
Okay, okay. Just please mail it, okay? Only then they will take note of it. If not, they won't know.
Okay.
Yeah. So the design speed on an expressway is 100 kilometers per hour. A vertical curve is formed due to an upgrade. So N1 upgrade, okay, so it is positive plus 3%, followed by another upgrade. So N2 is again upgrade, so it is plus 2.5%. The minimum length of the vertical curve in meters would be what? So, if you refer to sir slides for expressways, okay, uh, if you see this itself, you can see that the change in grade between these 2 points is only 0.5%. So, it was at 3%, then again the grade changed to 2.5%. So the difference between these two is just 0.5%. So it is the change is very minimum. Okay. So in such a case, they have given you a table to find out what is the minimum length of the vertical curve for this minimum um, grade change, right? So for my vehicle speed of 100 kilometers per hour, and if you see this problem, so my capital N, which is my deviation angle, is nothing but N1 minus N2, which is 0.5%. Okay. What is the minimum length of vertical curve? It is 85. Okay, so the answer to this is 85. Now moving on to the next question. So the value of grade compensation which should be implemented on a curve of radius 40 meters would be what? So before this, let us understand what grade compensation means. Okay, so if you have, we've all this while we've seen a horizontal curve separately and vertical curve separately. When you have both of them together, okay, you have a horizontal curve, and when you move along the horizontal curve itself, you are experiencing a change in the vertical curve, vertical grade. Okay, like when you travel on a travel to a hill station. Just see this figure. This is a horizontal curve, right? At the same time, there is an increase in the grade from this level. It is increasing to this level. In the same way, if you see here also, it is increasing and decreasing. Okay, so it is a combination of both horizontal and vertical curves. Now, what is the issue with combining horizontal and vertical curves? We would have experienced a difficulty in traveling when both of them come together. Okay, so in order to eliminate that difficulty only, they are asking you to compensate the grade, right? So to make it more clear, let us say you're traveling on a vertical curve. Okay, your vehicle is traveling on a curve. Let me put it in this way, and let me show you the top view. Okay, so this is at one level, okay, L1, and this is at another level. So my vehicle is trying to travel on this road where its level changes from L1 to L2, which means my vehicle is traveling on an upgrade. Okay, in such a case, it would require let us assume that the traction required is T, right? So what is traction? It is nothing but the force applied between the tire and the road surface. Okay, so in order to make it move. Okay, so on a vertical curve, the force required by the vehicle to travel on this curve is more. Okay, let us take this as T. Now if in addition to this uh, traction, so it has to pull the vehicle at a force of T. Now if there's a horizontal curve in its way, okay, then the traction force will be lost. Okay, so you will not have that efficiency. So if I'm turning my steering like this, let us say after turning this steering, this angle is alpha. Okay, so there will be a loss in traction force, and this loss is given by T minus T cos alpha. This loss in traction force will lessen your efficiency to pull the vehicle, right? So in such cases, so it will be difficult for you to travel on this travel on this curve where you have both a combination of both horizontal and vertical curves. So in such a case, what you should do is you should provide grade compensation. What do I mean by grade compensation? It is just a fancy term. It simply says that you have to reduce your vertical grade. Okay, so if your vertical grade is say 3%, and if you find out your grade compensation value is 1.5%, then you have to reduce your grade to 3 minus 1.5. So the final grade that you provide will be 1.5%. Okay, so that is called as grade compensation. You are compensating the grade so that your vehicle will not have difficulty in traversing in this portion of the curve. Okay. So how to find out this grade compensation? So let us see. So they've given you the radius of the curve. This is 40 meters. So let us see the equation for grade compensation. So grade compensation is given by 30 plus R by R. This is clearly an empirical curve. Okay, so let us substitute the value of R here. So 30 plus 40 divided by 30, and this will give me 1.75 percentage. So I have to express this in percentage. Okay, sorry, this itself is in percentage. Okay, so you need not express this in percentage. This itself is in percentage. Okay, now um, this is the grade compensation value that you got, but there is a maximum value of grade compensation that you can provide. So it means that I am planning to reduce the grade, but I should not go beyond a limit. Okay, so that also has to be found. So what is the maximum grade compensation that can be provided? So this should be less than that value. Okay, so that equation is given by 75 by R. Okay, now if this, so what is 75 by R? It is nothing but 1.875%. So this is the maximum grade compensation that you can provide for that portion of the curve. Now the value that I have found out is less than that, less than this maximum value. So I can take this, take the final grade compensation as 1.75%. So whatever grade that has been provided on this curve can be reduced by 1.75%. Okay. Okay. So to have moving on to both um, so moving on to coordinating horizontal and vertical alignment. Okay, so let us see a question on that. To have a better coordinated horizontal and vertical alignment design, the absolute minimum length of horizontal curve on a carriageway designed for a speed of 60 kilometers per hour is what? So I've taken this statement from search slides. So the length of the horizontal curve should be at least 3 times the design speed, or preferably twice the viewing length. Okay, so the minimum length of the horizontal curve is nothing but 3 times the design speed. So 3 into 60, which is 180 meters. So this is the minimum length of horizontal curve required to have a better coordination of horizontal and vertical alignment design. Moving on to the next question. So they've asked you, so this is the horizontal curve. So if you see, this is the total curve, and they've shown you the top view, which will show you the horizontal curve, and the side view, which will give you the vertical curve. Now imagine in this portion you are having this horizontal curve, okay, like this, and vertical curve. So if you see here itself, you can feel that there's a dip here, right? So that is what they have shown here, and they've asked you what is the type of flaw that is present in this design. They've asked you the name of this type of flaw. Okay, for this here, for this also I've taken reference from search slides. If you see, you have something called as fluttering. This is not the case for us, right? This is what you observed in the problem. So this has been named as diving, and so the answer to this question is diving. I'm not stressing more on the alignment coordination part. Okay. Yeah. So moving on to, so from here, let us start this week's problems. Okay. So this week had some of alignment coordination or design consistency. So let us see one problem related to that. Okay, a high-speed corridor is passing through a big town. The town section of the corridor is experiencing traffic congestion. Transport planner has provided the following two alternatives to ease out the congestion congestion and maintain the functional utility of corridor. Okay, so what are the two? So they've said, so what they mean to say is there's a high speed corridor which can be an expressway or a national highway, and this high speed corridor is to pass through a big town. Now the town section of the corridor, because of this, because it is in a big town, it is experiencing traffic congestion. This corridor, this section, town section, this section of the corridor is experiencing traffic congestion. So traffic planners have come up with two alternatives. They say that they have come up with two alternatives, and they're asking you to pick which one is the correct alternative, or if both are correct alternatives, or if both are wrong. Okay, both are not acceptable. So let us see the two alternatives that the traffic planner has come up with. So the high speed corridor should pass through a bypass which is connected to the town by spurs. Okay, let us understand this alternative. So you have the town section here. This is my high speed corridor. They say that this has to be connected by a bypass. Okay, and from this bypass you should have spurs, which is small sections of roads which enable you to directly access the bypass, okay, from the town. Okay, so these are called as spurs. Should you provide this, or so this is their alternative A. What is their alternative B is the existing alignment can be widened with control on access from roadside developments. So you have, say, a 4-lane road. They are saying that just widen the roads, okay, and provide access control. What do I mean by, so we already saw what access control is. You cannot allow the vehicles to access the highway, like travel on the highway, enter the highway, okay, this is the correct word. So enter the highway as and when they want, but you will provide access points to the highway which will tell them that you should enter the highway only at these points. So that is called as access controlled. So they're asking you which is the best option. Either you should you widen the roads, or you should you provide a bypass. Okay, so if you see, providing the bypass is the best alternative. Okay, so you will not go for widening the roads because it is already a big town which might be having a lack of space. So you should best option is to go with the bypass. Okay, so the answer to this is alternative A. Okay, from here on we will, from here on we will be seeing only about intersections and interchanges. Okay, now let me give a brief outline about intersection, and then we will move on to the problems. So what is an intersection? It is very simple. If two or more roads, okay, join, if they join or cross each other, so this is crossing each other. Say these two roads are joining, this is also an intersection. So two or more roads joining or crossing each other, that point, so this point is an intersection. Here this area is an intersection, right? Now there are many types of intersections. Just a second. Yeah, so this, let us, so if this is one intersection, okay, this is a crossing intersection, right? Two roads are crossing each other. In this intersection, these four roads, right, these four extensions are called as legs of the intersection or approaches. Okay, similarly, if you say you have a rotary intersection, okay, what is a rotary intersection? It will have a roundabout. Okay, this is my rotary intersection. It is called a 1, 2, 3, 4, 5. It is a 5-legged rotary intersection. So this you will call it as leg or approach. Now there are different kinds of intersections. So based on if they are at the same level. So there are two roads and if they cross each other at the same level, then you will call it as at grade intersection because they are at the same grade. If they cross each other at different levels, then you will call it as grade separated intersection. So one road will be at a higher level and one road will be at a lower level. This can be a subway or so oh sorry not subway, it is called an underpass or a flyover, right? So or an overpass. So we will see figures for all this, but just understand that an intersection can be an at-grade intersection or a grade separated intersection. If the two roads that are meeting or joining or crossing each other, if they are at the same level, then it is an at-grade intersection. If they are crossing each other at different levels, then it is a grade separated intersection. Also, this is based on the grade. Okay, now there's another the classification can be also based on priority based. Okay, if two roads are crossing priority, okay. If two roads are crossing each other, say if this is a major road and this is also a major road, this is an uncontrolled intersection with uncontrolled intersection. Why do I call it as an uncontrolled intersection? Because both of them uh, do not have any kind of control. It does not have a signalized control. So if it has a signal, then it is called a controlled intersection or signalized intersection. If it does not have any control over the movement of vehicles, then it is called as an uncontrolled intersection. Okay, so so if it has a signal, then it is called a signalized or a controlled intersection. If it does not provide any kind of control to the vehicle, then it is called as an uncontrolled intersection. And one more thing is what we call it as priority controlled intersection. So this we already saw earlier. When a major road is crossing a minor road, we ask the vehicles traveling on the minor road either to go slowly, right? We will provide a give way sign, which means you have to wait, like slow down your vehicle or stop your vehicle, allow the vehicles traveling on the major roadway to cross, and then only you cross, right? So either you provide a give way sign or you can provide a stop sign. So in such a case, the priority goes to the major road, right? So this kind of intersection is called as a priority intersection. So based on the control level of control that you have over the intersection uh, provides for the different roads on the intersection, it can be called as a controlled intersection or signalized intersection or an uncontrolled intersection or a priority controlled intersection. Okay, now based on by combining these two. Now, first we saw grade separated intersection, right? So that is a space separated intersection. So these two roadways which are crossing each other are separated by space. Okay, so they will cross each other in the same time. They can cross each other at the same time, right? Vehicles traveling on this road can travel at the same time as the vehicle which travels on this road, right? But they are separated by space. That is why they do not um, have any conflict. They can travel without having any conflict. So that is a space separated intersection. The other one is time separated intersection, which we just saw. So time separated intersection, the best example is a signalized intersection. Now you have two roads crossing each other. Both will not travel at the same time. Both will use the same space, right? They will use, so vehicles traveling on this road will use the same this portion of the roadway, and vehicles traveling on direction, in this direction, will use the same space, but the only difference is they will be separated by time. When vehicle is traveling in the east-west direction, uh, the vehicles in the north-south. So if this is the north-south direction, so if the vehicles traveling in the north-south direction will will be stopped here. And when vehicles travel in the north-south direction, the vehicles traveling in the east-west direction will be stopped, right? So this is what is called as a time-separated intersection. If you see, both these intersections are to reduce the conflict among the vehicles when they traverse through an intersection. Okay, so these are the types of intersection, and we just saw the basic examples also. Now let us see this problem and try to understand it. And now the option which is not an example of at grade intersection is what? Okay, just now we saw what an at grade intersection is. So an at grade intersection is, well, it will have both the roads at the same grade, right? So is always top intersection an at grade intersection? Of course, it is an at grade intersection. That is why you provide a stop sign. Since they both travel the same grade only, you're asking one vehicle to stop while you're asking the other vehicle, and while you're asking that vehicle to let the other vehicle go, right? So both of the roads are in the same level. So this is an at grade intersection. Is flyover an at grade intersection? No, because flyover, as the name says, and just as we saw, as I told you a few minutes back, one roadway will be at one level and the flyover will be at the other level. Imagine. So this is the flyover. It is traveling perpendicular to the system. Okay, so this is one level and this is one level. So this is my flyover. So this is not an at grade intersection. So flyover is not an at grade intersection. Signalized intersection, of course, it is an at grade intersection. That is why you provide signals for grade separated intersection. There's no need for signal at all because both of the so the vehicles traveling in both of the roadways can travel at the same time. So signalized intersection is an at grade intersection. Uncontrolled intersection, we also saw that uncontrolled intersection is both the vehicles. So both the roads will be of equal importance. So you are not providing any control over it. At the same time, you are not providing you're asking it to asking both the vehicles to travel at the same time and at the same space. So it is neither time controlled nor it is neither time separated nor space separated. So uncontrolled intersection is one such example. So it is an at grade intersection. So the answer to this is flyover. Okay. Now moving on to the next example. Example of time and space separated intersection respectively. Okay, so which one is, so let us mark the time separated intersection. A signalized intersection or time separated intersection? Yes, we saw. Priority intersection is a time separated intersection. It can be, but we cannot be sure because um, you are not giving separate times for the vehicles to cross, but you're asking the vehicles to um, make the decision. Okay, so this may not be a time separated intersection. Okay, so this one is wrong. So flyover time separated intersection. Flyover comes under space separated intersection, right? So this is also not a time separated intersection. A signalized intersection or time separated intersection? Yes. So already 2 and 3 are ruled out because the first example is not an so the first case is not an example of time separated intersection, but still we will see the second option for space separated intersection. So it is interchange a space separated intersection? Yes, because interchange is a grade separated intersection. Okay, interchange means you have two roads at different grades. So that is why you call it as an interchange. Okay, so yes, it is a space separated intersection. Is signalized intersection a space separated intersection? No, it is a time separated intersection. Is interchange? Yeah, again, it is a space separated intersection. Is Y intersection a space separated intersection? So Y intersection is nothing but this is a Y intersection, okay, and this will come under at grade intersection. So at grade intersection is not a space separated intersection, so this is um, not correct. So the answer to this is A, okay. So moving on to the next question, examples of at grade intersection classified by shape, okay. So since Sir has already cleanly shown in the slides the shape of different at grade intersections, okay, uh, classify so at grade intersections classified by their shapes. So I don't want to show all that, but let us only see what uh, what these four options look like so that you can make the correct choice, okay. You know what a rotary intersection is. It is nothing but a roundabout, okay. So is this an at grade intersection? Yes, a rotary intersection is an at grade intersection. You will also have rotary interchange, okay, so that is different, okay. So this is an intersection, so it is an at grade intersection. So this is one of the correct answers. A four-leg staggered intersection. So what is a four-leg staggered intersection? So this do you see four legs here? One leg, two, three, four. You have four legs here. But instead of these two roads crossing exactly like this, you are staggering the cross. Okay, you are providing some distance between these two roads to reduce the conflict points. We will see what conflict points are. Okay, so this is an at grade intersection and it is classified by shape as a four-leg staggered intersection. Now coming to trumpet intersection. So if you see, it will kind of look like a trumpet. So you will have something like this. Okay, and also roads traveling here. So if you see from this figure itself, they both are at different grades, right? So one is at a lower level, this road is at a lower level, and this road is at a higher level. So this is not an at grade intersection, but it is a grade separated intersection. So trumpet is not the right choice for this answer. And Y intersection we saw, so this is a Y intersection, right? So this is an at grade intersection. Okay, so the answer to this is rotary, four-leg staggered, and Y intersection. Now moving on to the next question. So let us come to conflict points. Okay, a two-leg. So before that, let us understand what conflict points are. Let us take a simple example. In this case, okay. So you have two roads crossing each other, and they both are one-way roads. Okay, two-lane, one-way. Okay. Let me use a different color. Okay, so two lanes means you will have vehicles traveling in one lane and vehicles traveling in the other lane. So I told you that it is just one-way traffic in both the roads. Okay, in the same way, you will have vehicles traveling in one lane. This is the second lane. Okay, so vehicles are traveling in this direction here, and vehicles are traveling in this direction here. Now, what are the possible points where the vehicles traveling in both roads, okay, could collide each other? If you see from this figure itself, when the vehicle travels in this direction, and if simultaneously another vehicle travels in this direction, both of them could collide at this point. So this point is called as a conflict point. Similarly, you can identify conflict points at each location, right? So if the vehicle is traveling in this direction, if it comes here, and if it collides with a vehicle traveling in this lane, in this direction, okay, so this is the second conflict point. Similarly, these 4 points are conflict points, right? Now these are called as cross conflict points, okay? So these are major conflict points. Just a second. right? So these are called as cross conflict points, are called as major conflict points. Now let me say that a vehicle in this direction has to travel, so has to turn and move to this direction, okay, like this. Let me use a different pen, okay, like this, okay. So here it will diverge from this traffic and it will merge with this traffic, okay. So here also you have a chance of colliding with the vehicle traveling in this direction, right? So this is called as merging conflict, right? And this is not as serious as cross conflict, okay? So you will call this as minor conflict point. So this is one conflict point. So you have four major conflict points and one major conflict point here. Similarly, you cannot go from this direction to this direction, right? Because it is only one way. So you can go from here, right, to here. Okay, if you want a vehicle on this road to go to change the direction to this road, you will call this as, it will merge here, so you will have one more merging point here, okay. So this is called as uh, yeah, so this is called as merging conflict, and this is a minor conflict point. So for one way, two lane, two lane, four-legged, you have four legs, right? uh, Uncontrolled intersection. So if you see, all this will happen only if you do not provide any control like signals. If you're providing signals, what will happen? You will provide signal. When you provide signal, stop here. When you stop the vehicles in this direction, only vehicles will be moving in the east-west direction. So this is the east-west direction, right? So in such a case, there's zero conflict, right? Similarly, when you stop the vehicles in the north-south, in the east-west direction, only vehicles will be traveling in the north-south direction. So the conflicts, there is zero conflict. So this conflict points will arise only when you have an uncontrolled intersection. Okay. So in order to reduce the conflict points only, they have a number of options which we will see later. Okay. So for a one-way, two-lane, four-legged uncontrolled intersection, how many conflict points are there? We have four major conflict points and two minor conflict points. So the total number of conflict points is 6. Okay. So this is just an example. Now let us come to the um, real question. Okay, a two-lane, four-leg, uncontrolled intersection with pedestrian crossings. Okay, so this is the example. So what is the question? Two-lane. Right. So one lane, it is two-way traffic. Okay, so one lane it will be traveling in one direction, and in the other lane it will be traveling in the other direction. Same here, one lane it will be moving in this direction, and the other lane it will be moving in this direction. Okay, so you already identified four conflict points here. Now, what are the possible motions you can imagine? So, in order to identify that, just imagine yourself in each of the direction. Okay, so let us imagine that you're here. Okay, where are the possible directions that you can go? One is straight ahead. You did that. Second one is you can turn to the left, right? When you do that, you create a merging conflict here, right? Now the third direction is you have to go to right. Okay, either you can go straight or you can go left or you can go right, right? When you went left, you made this merging conflict. When you went straight, you made this two conflicting crossing conflicts. And when you go right, okay, So here you will make a merging conflict, right? So here also you will make a merging conflict. Now so you've finished your so you imagined yourself in one direction. Now move to the next direction. So stand here, you're moving straight, then you're moving left, and then again you're moving right. Okay, in the same way you have to draw for all the four directions. So you did this for here. Now imagine yourself here, left, straight, and then again right here, right? In the same way, imagine yourself here, straight, left, and then here, right? So when you do this, you have four major conflict points. You have four minor conflict points. Okay, sorry, four major conflict points you have as of now. Okay, minor conflict points you have 8 because you have merging in the left direction and also merging here in the right direction for each leg, right? So you have 8 minor conflict points. Now if you see here, you are making conflict points here also. Okay, wherever you cross, you just identify that as a conflict point. Okay, so you have 4 more. Okay, and also maybe I will tell with respect to this, okay, because it is more clear. We saw straight, left, and then right, right? So these four conflict points we saw. These four conflict points we saw, which are major conflict points. Now if you see wherever it is crossing, it is a conflict point. Here it is crossing 1 2 3 4 5 6 7 8. So you have 8 more cross conflict points. So you have 4 plus 8, okay, cross conflict points. Minor conflict points we already saw, it as 8 merging. Okay, so totally you have 24. Now 24 is the answer in the normal case. They've asked you conflict points with pedestrians also, with pedestrian crossing also. So where will you usually provide pedestrian crossing? You will provide it here, right? Okay, here. So in such a case, in each leg you have two conflict points where you possible places where you could collide with the pedestrians. Okay, so totally 8 conflict points for pedestrian conflicts, right? So totally it will be 24 plus 8. So if you have any doubt, just draw and then you identify the points which are crossing, okay, where the lines are crossing each other. So all that are called as conflict points. Okay, so this is how you will identify conflict points. Now moving on to the next question. With respect to descending number of conflict points, the correct arrangement of two-lane at grade intersection with bidirectional traffic. Okay, so let us take a moment to understand what are the possible solutions for minimizing conflict points. Okay, so first you can convert an intersection into a roundabout. Okay, so I can convert this like this. Okay, so in such a case, if I do this, instead of I won't be directly, there won't be cross conflict points at all. It will reduce the major conflict points. Okay, so if I want to go straight also, I will just go make a turn and go here also. So everywhere it is just kind of merging. So when you do this, from 32 you will reduce the conflict points to 12. Okay, so you provide a roundabout. That is one option. Other option is easy. You provide a signal so that you will not allow vehicles traveling in different directions to travel at the same time. So you're reducing the conflict points completely. Okay. So okay, we will talk about reducing conflict points in signal sections later. Okay, so first is so you can provide roundabouts, you can signalize an intersection, or you can provide a channelization. So what do I mean by channelization? Let us take a Y intersection. Okay, so here if I provide a channel like this, okay, vehicles, if they want to travel without a channel, okay, they will simply turn like this. Okay, so this will create conflict points with these vehicles, with vehicles traveling in this direction, right? So in such case what they will do is they will provide a channel, so you have to move around the channel, kind of like a roundabout. Okay, so you can channelize the section. You can um, instead of making it uncontrolled, you can make it priority controlled. Okay, or stop control. You can provide give way signs or stop signs, okay, such that the driver will be cautious and will traverse the intersection only when the road is free to traverse. Okay, okay, and then we saw staggered intersection a few slides back. Okay, we saw instead of this, if you just stagger the intersection, okay, this will reduce the conflict points. Okay, instead of okay, so this is a left right stagger. Okay, so you have left and right stagger. This is a right leg stagger. So they say that this is better. So right leg stagger, right left stagger is better than left right stagger. So providing a staggered intersection is also intersection also reduces the number of conflict points. Okay, and also they say that you have to control the right turning and left turning traffic. So you have to provide separate provisions for right and left turning traffic. So what do I mean by providing a separate provision? Instead of so if you are traveling in this lane, okay, if you want to travel to the you have to make a right turn. They say that providing a separate provision is they will provide a separate lane at the end of this intersection exclusively for right turning vehicles. Okay, so this is providing a exclusive lane for or a separate provision for left and right turning traffic. Okay, so this will also reduce the conflict points. So if you come here, come back to the question. Yeah, so you know that how arrange them in the descending order of conflict points. Okay, a four-legged and unsignalized intersection has the maximum number of conflict points. So already the options 2, 3 and 4 have been ruled out. Okay, so after this comes the roundabouts. Okay, because all these will have four legs, right? A T junction will have only three legs. So compared to these two, a T junction will have lesser number of conflict points. Okay, so the order is four-legged unsignalized intersection, followed by roundabouts, and followed by T junction. Okay, so this is the option B is the correct answer. So now moving on to the next question, the salient features of service interchange. So let us see the types of interchange. So we already saw that interchange means they are at two different grades. Okay, so they are yeah, they are two roads crossing at two different grades is called an interchange, and you can have interchange with ramps and interchange without ramps. That you will that we will see a little later. So for now they call something as service interchange, and they've asked you what its salient features are. So to understand that, let us see the types of interchanges. So there are two types. Okay, it can be classified into many categories, just as we saw based on a level of control. The intersections can be classified different ways. The based on shapes, they can be classified as different ways. Similarly, uh, based on this criteria, okay, based on a criteria, they can be classified as service interchange or system interchange. Okay, so what is a service or system interchange? So if a if a freeway, or if a not a freeway, if a high corridor vehicle, say not high sorry if high speed corridor, okay, say an expressway, highest level of roadway, okay, is connected to the local streets, okay, local streets or arterials or sub arterials, okay, um, then it is called as a service interchange. So what I mean to say is, imagine there are uh, two roadways which are separated by a grade, okay, they are at two different levels, okay. Among these, one is a major roadway and the other is a local roadway, local street, okay. So if ramps have been provided, if access is provided, so if connection is provided between these two, then it is called as a service interchange, okay. What is a systems interchanges? Both are major roadways and you provide connection between these major roadways using loop ramps or any kind of a network of ramps, okay. So major differences: service interchange, a major road is provided, so major road and local roads are connected via ramps, okay. They are first separated by a great difference, and then they are connected by ramps. um, on the other hand, system interchanges, both both the roadways crossing at different levels are major roadways, and they are connected by a system of, or a network of ramps, okay. So yeah.
It is between the connection.
uh,
The difference is only between the different
no
roads,
no
not by
no
the connection.
by
So
connection as in,
major and major, it is connected. If it is connected a major road with a major road, it is a
ah
system interchange.
yeah,
It is a major road connected with a local road. It is called as.
service interchange.
That's the only difference, no?
No, there are a set of differences, but the major difference is this,
Okay.
okay. So that is why a service interchange will not have any free, it need not maintain a free flow because it is connected to a local roadway, right? Whereas um, these two will maintain a free flow because they are major crossings, okay. So this is, as per Sir slides, this is the main definition, that a service interchange does not maintain a free flow, whereas a systems interchange maintains a free flow. What I understood from literature is, besides this example, besides this difference, one more difference is, a major roadway is connected to the two roadways that are crossing, one is a major and one is a local roadway, and they are connected by ramps. And for a systems interchange, both of them are major roadways and they are connected by ramps. Okay, so in this service, since it is at a lower level, right? Since it has a lower level of roadway crossing, it can have an at-grade intersection also in the vicinity. Whereas a systems interchange cannot have an at-grade intersection, okay? Because both of them are at highest level of roadway. Both of them are highest level of roadways. So providing an at-grade intersection is going to create a lot of conflict points, okay? So these three are the major differences for service and systems interchange. Now, the salient features, they do not have access, they do not have ramp to access. No, it is not correct. They do not maintain the flow through all of its elements. As I said, in search life, the major point is that that they do not maintain free flow through all its elements. Okay, so this is one of the salient features. Is an intersection of major road with a major road? No, it is a intersection of a major road with roads of lesser importance, such as arterials or subarterials. Okay, and they are useful for three-way junction with weaving. So this is also not correct. Okay, this you can, yeah, this you can see from Sir's slides that it is useful for three-way junction with no weaving. Okay, so it uh, contradicts here. So the answer to this is just B. Now moving on to the next question. An acceleration lane at an intersection allows what? Okay, before this, let us understand what an acceleration lane is. Uh, so let us take a roadway and let me draw. So this is one roadway. This is another roadway. Both are at different levels. Okay, so that this is a minor road with a lesser speed, and this is a major road. Okay, uh, both can be at the same level or different level, but just imagine that both of them have different levels of importance. One is a minor road and the other is a major road. So, what is an acceleration lane is, now my minor road, the speed of the vehicle, let us say that it is 50 km/h, and the road on the major, so the speed of the vehicles on the major road is 100 km/h. Now, if I travel to switch from this road, so I want to move in this direction, I have to increase my speed from 50 to 100 km/h. But here I'm traveling at 50 km/h. When I'm turning, I cannot make it to 100 km/h because it is a risk. So I have to make it to 100 km/h and then only enter this highway. If not, it is going to reduce the efficiency of the highway, right? Because all these vehicles will be traveling at a design speed of 100 km/h. Only then um, uh, only then the roadway can function efficiently. But if I keep intruding that roadway by my lower speed vehicles, then its efficiency is going to be reduced. The speed of the vehicles coming behind it will be reduced. In such a case, I have to make sure that I enter the road. So when I enter the roadway, my speed has to be in par with the vehicles traveling on the major roadway. Okay, so for that, you will be provided with acceleration lanes. So what it means is, you're traveling at 50. When you reach this place, you won't be 100, but they will provide you some distance so that you can increase your speed from 50 to 100. And by the time you enter, so when you're ready to enter, you will be exactly 100 kilometers per hour. Okay, so this is an acceleration lane, right? So if you see here, so this is a grade separated uh, road. Okay, some vehicle from a lower grade is entering. That is why you are provided with a ramp, right? Ramp is connecting roads at two different levels. Okay, so you travel on the ramp, and then you are provided with an acceleration lane which is not part of the major roadway. Okay, so from here to here you will be able to increase your speed, and then when you enter the traffic stream, your speed will be what is required for the major roadway. Okay, so let us see left turning traffic from major roadway. Okay, in the same way there is something called as deceleration lane. So if you see this figure, this is a major roadway. The vehicles will be traveling at say 100 kilometers per hour, and I have to reduce. So when I enter, so if I leave this major roadway, I may be entering a roadway. Okay, a minor roadway. Okay, so in that case, vehicles here will be traveling at 50 kilometers per hour, and I cannot enter the roadway with my speed of 100 kilometers per hour because it will create accidents. So in such a case, there's something called as deceleration lane where I will bring down my speed from 100 to 50 in this deceleration lane, and then I will enter the ramp and reach the minor roadway. So these are uh, acceleration and deceleration lanes. So what you should remember is acceleration lane is for your vehicles to move from minor to major roadways, and deceleration lane is for your vehicles to move from major to minor roadways. Okay, so left turning traffic from major roadway to diverge on a minor roadway. So if you see it is from major to minor, so this is not the correct answer. Left turning traffic from minor roadway to merge on a major roadway. So it is basically for left turning traffic. Okay. So I told you, right? It is for a vehicle traveling on the minor roadway to make a left turn. To make a right turn, you will not be provided with you cannot be provided with an acceleration lane. Like where will you be provided, because it is difficult. Okay. So it is usually for left turning traffic traveling from a minor road to a major road. Okay, so this is the correct answer. Through traffic to accelerate and cross the intersection. This is also not the correct answer. It is not. Through traffic is vehicles traveling straight ahead. Okay, in an intersection, a vehicle traveling straight ahead is what you will call it as a through traffic, and acceleration lane is definitely not provided for such vehicles. Okay, so the answer to this is left turning traffic from minor road to merge on a major road. Remaining, there are seven more questions. I think since next week also we will be talking only about intersections, I think we will see this next week. If you have any questions, please feel free to ask.
There is one doubt in the assignment.
Okay.
Actually, calculating the tangent length, the formula is LT by 2 plus R plus N S into tan delta by 2. So, okay, no?
You're asking me if it is correct?
Tan delta by 2 or tan theta by 2.
Uh,
It should be
just a
tan
second.
delta by 2, I think.
Yeah, I think so. It should be tan delta by 2. The question, so it will have, is it the sheet which I gave?
It's a fourth question.
Which assignment can you please say?
Fourth question from the last assignment, week 8 assignment.
Just a second.
In solution also it is taken as tan theta by 2.
And theta stands for?
Theta is angle of circular curve. It is the transition plus circular curve.
Huh.
The tangent
Just
length should be LT by 2 plus R plus S into tan delta by 2.
yeah, just a second, just a second. Yeah, tan delta by 2.
Okay. We are taking, but in solution it is taken as tan theta by 2.
Theta is the angle of the circular curve.
Circular curve, circular curve.
Mm,
It shouldn't be, I think. If it is a with transition, it will be tan delta by 2 only because we are taking LT is up to tangent. LT by 2 is up to tangent.
Yes, because delta from the deflection angle only you will be finding out angle of the circular curve, right?
Yeah.
Yeah, you won't be provided with angle of the circular curve directly.
Okay. Okay.
You will only get deflection angle. From
Yeah.
that only you can, yeah.
Yeah. Thank you. Thank you.
Yeah, sure. Is that all? Can we end this session?
Yes, ma'am.
Yeah. Thank you then.
Okay, ma'am. Thank you, ma'am.
Thank you.
Thank you.
Thank you.
Thank you, madam.
Yeah, thanks.